Before creating the VRF, let's recap the current state of the cluster and entire setup to understand all the changes that will follow once the VRF is created in Cilium. So we have the BGP peering and locator defined in the previous step, which means that if I go to top of rack, where we have IPv6 address family being exchanged, the network is the locator is advertised over the BGP session, re-advertised to ISIS, and all the nodes in the cluster in the network will know how to reach that locator. The sessions, BGP sessions here all up, but nothing is advertised yet. Something should be sent from P6 towards the cube clusters, but I believe it will be simply dropped by BGP sessions on the receiving side. If we check the CE11 route table, it will just get the route to the remote CE12. CE12. Yes, we see that here. CE12, right? And I could do the same on every other CE location to get similar type of output. So that's the starting moment. Egress policy is not defined yet, and eBPF maps related to SRv6 are all empty. That's our starting point. So let's create a VRF. VRF needs a name, ID, existing pool reference name. The route targets will dictate what will happen on the BGP VPN v4 level. Port label selector will control which pods will become part of the VRF based on the label, and destination CIDR will control the forwarding from the pod to the outside world and vice versa. So here I say that this VRF, as defined so far, will be allowed only to communicate with the CIDR like this, which is the CE11 local network. And I do it for a purpose. You will see that in a minute why I do that this way. I create the VRF. API is right now has been sent to Kube cluster, and in a moment we will see the outcome on the screen. So what's the outcome from the VRF object perspective that we here visualize from also with other objects, as well as we can see that in the row Kube categories. The VRF is created, it gets the locator, it gets the seed from the locator on every cluster node. If you remember, that was the locator, that was the big locator that was the locator pool. That's the locator. That's the locator for the node. So that's common. You see on every seed, and that the last 16 bits are different. 16? No, not 16. 8, right? 4. And then we have also the function. We have also the function which is allocated dynamically for every for that VRF. So these are the locator seeds, and we also have the definition of pod selector and destination CIDR. This what's shown below are the pods that have already this label pre-configured. So as soon as I created the VRF, then Cilium will converge and say, okay, these are the pods that are already part of the VRF. Obviously, I could have done it differently. I could first create the VRF and only then create the pods, but it also can be done in a different order. So let's analyze what has changed. Let me go here. We see here that the blue line went up, but only blue line is for the TA11 probe. Why is that? Because .VRF is not configured. That's point number 1. Point number 2, that even if VRF1 is configured, I've only enabled 10.10.11 subnet as the destination CIDR, not 10.10.12, right? Which means that if I go to topology, it means that the traffic is only allowed to go like this, looking at my mouse, not like this, even if Orange VRF is configured on the kube cluster. So the destination CIDR is controlling the packet flow. So let's maybe check what's changed, what has changed on from the BGP perspective. No change is expected here, because here we advertise IPv6 CIDRs, so the pod CIDR as well as locator is unchanged, keeps on being advertised, nothing has changed here. But things have changed here. From a route reflector perspective, we have, instead of 0, we have one VPN v4 networking being advertised. If I select it, I scroll down what's advertised. We have the route distinguisher, we have the network advertised by control plane node, and we have the locator. Let's keep in mind like this. This network is the IPv4 CIDR of that node. Again, IPv4 CIDR of the pod, of the node, not the pod /32. So look at that. Control plane, if I go to nodes, it has this subnet, and that subnet is advertised over VPN v4. And I will not change it again. You can go back with the recording to see that the IP SRv6 TLVs in VPN v4 shown here correspond to a seat that has been allocated to that VRF. So that information is sent over reflector, and based on the it's then to C11 and C11, it will have IP4 it has previously on this side, which is remote. Not with that option VRF established by every node, right? VPN v4 is exchanged on every node. So four new PEs started to advertise its own pod CIDR. This one, this one, this one, and this one, right? And they are reachable and they are routable. The same goes for C12. C12 also has these networks. So why, if this guy knows these networks, why we still don't have traffic coming from TA12? Is that why the yellow is down, right? Extension cyber that I have defined with your the eBPF map. So we see here the policy map has been populated with what? Actually, we mostly care about only this part. This is based on the destination side C11, C12. This is the seed that has been advertised via VPN before by P11 and P12 to route reflector and then to Kubernetes nodes using BGP. Then on the seed map, we have the locally. So this table might be a bit confusing. Keep in mind that this table is, instead of having 4 tables, it's like table per node. So control plane node will just have this entry, worker node will have just this entry, etc., and so on, right? And this entry contains what? The seed. The seed that has been allocated per node per VRF. Last but not least, we have the SRv6 VRF map. That's where we have for all the pods which are part of the VRF, and these pods have an IP address, right, like every other pod. We know that these pods can actually communicate with only that CIDR that has been configured in VRF. And basically that's the result, that the yellow line is down on Grafana dashboard. So let's change that. Let's go to VRF. Let's edit the VRF. And let's add another network. It is updated. Let's check eBPF map. Things have changed, right? We see 12 added. If we go up here, hopefully we should see 11 yellow line. Enabled traffic on the same VRF going to another subnet, which in our topology is behind CE12. Yeah, the same can be done for VRF2 or green one, but let's not waste time on that. You know the drill.